Hello and welcome to my channel. I am Mensa Augustine. Please, if you are new here, kindly subscribe to my channel. Now, Harriet from the University of Ghana Legon called me and asked me this question. Said, do we have specific functions that we use the natural logarithm to differentiate? Harriet, the answer is no. We can use the general logarithm to differentiate any function, but some of the functions are very simple for us to differentiate, so there's no need using the idea of the general logarithm. Look at this one. If I have y equal to x squared and I want to differentiate, I can take natural log of both sides. That is, natural log of y equal to natural log of x squared. Natural log of y equal to 2 times natural log of x. Here we are differentiating implicitly. So we are going to have, if we differentiate y with respect to y, we get 1. We divide it by y, since we have natural log. Then we attach dy on dx equal to, if we differentiate x with respect to x, we get 1 divided by x because of the natural log. Then times 2. So we have 1 on y, dy on dx is equal to 2 on x. Now, if we multiply here by y and multiply here by y, we have dy on dx to be equal to 2y divided by x. And what is y? That is x squared. So you have 2x squared divided by x, and that is 2x. So Harriet, you see, I took natural log of both sides. I've gotten this answer. So this is a very simple question. You don't need to go through all these steps to get there. Just differentiate it. Dy on dx equal to 2 times 1 is 2, and the power 1 will get x. But if you get this type, let's see, if you have f of x equal to the cube root of, I have a very nice question here, x squared minus 2 divided by x squared plus 4. Here, f of x is equal to x squared minus 2 divided by x squared plus 4, all to the power 1 out of 3. You see that this one, if you want to differentiate the inner one, you have to use the quotient rule, and you have to use the chain rule. So this one will take you a lot of time. So a very simple approach is to take the natural log. So we take natural log of f of x equal to natural log of x squared minus 2 divided by x plus 4. Sorry, x squared plus 4, all to the power 3. You have natural log of f of x equal to 1/3 of natural log of x squared minus 2 divided by x squared plus 4. Then we have natural log of f of x equal to 1/3 of natural log of x squared minus 2 minus natural log of x squared plus 4. You see that this one, it has become very simple. So I'm emphasizing that you can use the general logarithm to differentiate any given function. You can take natural log of both sides and then you start differentiating. Very simple. So here we have f prime of x dy. Sorry. If we differentiate this, we are going to get 1. Okay, let's make this equal to y so that we get it. Let's say this is equal to y. Let's say it's equal to y, right? But if you want to use f of x, we write f prime of x divided by f of x as the derivative. If you have natural log of f of x and you want to differentiate, you differentiate f of x to get f prime of x, then you divide it by the same f of x. So that's the derivative of this. But I'm using y there. So here, I'll have 1 divided by y, dy on dx, implicit differentiation, is equal to 1 out of 3. If you want to differentiate this, we have 2x divided by x squared minus 2 minus, if you want to differentiate this, 2x divided by x squared plus 4. Bam. Now, I'm going to multiply 2 by y. So I'm going to get here times y and here times y. So I'll have dy on dx to be equal to y times this will give me y divided by 3 times 2x divided by x squared minus 2 minus 2x divided by x squared plus 4. Now, what is y? Y is equal to f of x, that is the original function. So, let's see. Here, 3 is here. Let me have the board so that I can do it very, very nice here. 3 is there, so the derivative of y with respect to x is equal to, this is y, because I said that I'm letting y equal to f of x. So I'm going to write x squared minus 2 to the power 1 out of 3 divided by x squared minus 4 to the power 1 out of 3 as my y. The numerator will take the power and the denominator will take the power. That is what I've done there. And you have the whole of this divided by 3. Are you okay? So since it is divided by 3, I can multiply it by 1 out of 3. So that the 3 will come in front of this. Very simple. Times 2x divided by x squared minus 2 minus 2x divided by x squared plus 4. Now, we are going to send this one inside. So, we are going to have 1 out of 3 wait for us. So, if this multiply this, what is at the top, we have the same at the denominator. So, what are we going to get? Let's first write our 2x divided by x squared minus 4 to the power 1 out of 3. Now, this one is carrying power 1. So you see that here, 1 is greater than 1 out of 3. So don't go and take 1 from 1 out of 3. Just take this one from that so that the function, this term will remain here. Check the trick. I'm going to divide this by that. This is x squared minus 2. This is x squared minus 2. Power 1. Power 1 out of 3. 1 is greater than this. So I'll take this power from this for the function to remain at the denominator. So I have x minus 2. Then 1 minus 1 out of 3 will give me 2 out of 3. So this will give me power 2 out of 3. Very, very simple as that. Minus here, this will multiply this. I'll have 2 times x squared minus 2 to the power 1 out of 3, all divided by this will multiply that. And I'm going to have x squared plus 4 to the power 4 out of 3. Because I have 1 out of 3 plus. This is also to the power 1. So 1 plus 1 out of 3 will give me 4 out of 3. This is a very nice question. Wow. So, yes, this is 2x. I hope we can leave our answer here. Very, very simple as that. You can leave our answer here. You can still simplify it further, but let's leave the answer here. So I was just trying to explain when to take natural log. You can take natural log of any function that you'll be given to differentiate. But for simple ones, just differentiate them. If you get something like this, or let's say that you have been given y equal to secant of x times cotangent of x divided by square root of x squared minus 1 times tangent of x squared. If you have this one, what do you do? You have to take natural log of both sides so that this will break down for you so that you're able to go about it. Thank you for watching. Bye bye.